Graph the system of linear inequalities. We have x plus y less than or equal to 7 and y plus 4x greater than 2. The first thing I notice is that neither of these are in the slope-intercept or y equals form, and it really helps if when you're graphing these, you get the y on one side and everything else on the other. So the first one I'm going to go ahead and look at is the x plus y less than or equal to 7. I know that I can go ahead and move that x to the other side by subtracting it. When I do that, the x's will cancel out on the left, and I get y less than or equal to negative x plus 7. From here, I can see that my y-intercept is going to be b, where it crosses the y-axis, is at 7, and my slope is at negative 1. So if I was going to go ahead and graph this, I would notice that I have that y less than or equal to. Less than or equal to is a solid line. And because y is less than or equal to, we know that we will be shading below or going down the y-axis. Now the other one we have is y plus 4x greater than 2. So when I look at this one, to get y on its own by itself on one side of the equation, we'll go ahead and subtract 4x to each side. When I do this, the 4x's will cancel out on the left, and I end up getting y greater than negative 4x plus 2. From here, I can get my y-intercept, my b, which is equal to 2, and my slope, which is equal to negative 4. Because I have a greater than symbol, we know that this is going to be a dashed line, and since it is y greater than, we know we will be shading above or going up the y-axis. Now that I know how to graph, now I know what everything is going to look like on my graph. What is the difference when I am graphing systems of linear inequalities versus just graphing one? What happens when I graph two or more on the same graph? My teaching assistant Chloe is here with her latest cheat sheet notes. First up, she wants you to know that when you are graphing inequalities, go ahead and graph all the inequalities and shade them on the same coordinate plane. Where all the shading overlaps, that is the solution. If you have any solid lines, those are included in the solution. If you have dashed lines, those are not included in the solution. Now that we have Chloe's cheat sheet notes over here, let's go ahead and look at what these look like when we graph them. We know that we're going to graph both inequalities on the same coordinate plane and shade them. That way we can see where they overlap so we can find the solution. So the first one I'm going to do is graph that first one here. When we had x plus y less than or equal to 7, we got it in this form here, where we can see our y-intercept is 7, and then our slope is negative 1 over 1, negative 1 over 1. Solid line, and we are going to shade below. So shading below this would mean that we are going down the y-axis, and that would end up looking like this. Now, on a separate graph, let's first look at what this one looks like. Y plus 4x greater than 2, or we got it into the slope-intercept form, y greater than negative 4x plus 2. So on that, we would have a y-intercept of 2, and we have a slope of negative 4, so that would go down 4, right 1. We figured out it was a dashed line and that we would shade above it. So shading above it would be up here on this top part. So now I'm going to use Chloe's cheat sheet notes, and I'm going to graph both of these on the same inequality, the same coordinate plane. So you can see I have my solid blue line here where we shaded below, and then we have our dashed green line where we shaded above. What can help when you are doing this is to draw arrows. So this blue line, we knew we were shading below, so I'm just going to draw a couple blue lines, blue arrows, knowing that I shaded down on that. And then the green dashed line, we had to shade above. So I'm just going to draw some green arrows going up. And the part where both that green and blue overlap was this area right here. This is where our solution to the inequality would be. Anything that is in this section here would qualify. So on this problem, all we had to do was graph it, but it does help to graph them both on the same so you can see the solution as well.